9.5, finding unknown angle measures. All right, so if you need to find the measurement of something, what do you normally do? If you need to find the measurement of something, you get a ruler out, you get a tape measure out, and you actually physically measure it. So today you're going to find angle measurements, but you're not actually physically going to measure anything. You're going to use something called angle relationships to find the measurement of the angle. So it's actually a pretty cool concept. You can literally find out the exact measurement of an angle without actually measuring it. All right, and we do that through what I just said, angle relationships. There are 4 different kinds of angles that you're going to learn today. All right, so I'm just going to kind of throw them out there. And then in the next example, we're going to look specifically at which angles would match this criteria here. Okay, so adjacent angles occur when two angles are adjacent when they share a common side and they have the same vertex. All right, in your notes, I said something about 180 degrees. We're going to take that off for now. Those are actually adjacent supplementary angles, which we're going to cover down here. Okay, so for adjacent angles, I need you to remember 2 things. They share a common side and they have the same vertex. You say, what in the world is a vertex? Well, in order to make an angle, all right, so let me just show you here on the slide. In order to make an angle, I have to have one side and I have to have another side, right? 2 sides make that angle. The point where those angles meet, that is called the vertex. All right? So 3 points make up an angle. So let's say there's a point here and a point here. And we have A, B, and C. Angle B is the vertex, all right, of A, B, and C. All right, angle A, B, C. So vertex is the point where 2 sides meet. You with me on vertex? Because I'm going to say vertex over and over today. So the vertex is where 2 sides meet to form the angle. All right. So adjacent angles share a common side and have the same vertex. We'll talk about adjacent in a minute. I'll show you what it looks like. Complementary angles are 2 angles whose measurements add up to 90 degrees. So let me just ask you real basic. If 2 angles have to add up to 90 degrees and one angle is 40 degrees, what would the second angle have to be in order for them to be complementary? It has to be 50. So would you agree there's a lot of combinations that could be complementary angles? It doesn't even have to be exact. I could have said 41 and 49. Right? I could have said, well, I don't know, give me another combination of angle measurements that would be complementary, meaning their sums are 90. Can anybody else give me a combination, Hadley?
30 plus 60.
30 and 60. Samuel?
52 plus 38.
All right, there we go. I like that. 52 plus 38. Aiden, one more?
89 plus 1.
89 plus 1. All right, I knew somebody was going to do it. 90 plus 0? No, you can't have a 0 degree angle. You can't have a 1 degree angle though. So complementary angles add up to 90 degrees. That's important. So if you know one angle, you could subtract it from 90 to find the other angle. We're going to be doing that in just a minute. Supplementary angles, okay, they lie on the same line. Did you know the measurement of a straight line is 180 degrees? Did you know that? Okay, the measurement of a straight line is 180. So if there's 2 angles that make up that straight line, that their measurements have to add up to 180 degrees. Supplementary angles lie on the same line and their measures add up to 180. Then we have vertical angles. Vertical angles share the vertex. Okay, so let's say, I'm going to kind of extend off this diagram a little bit. All right, and I'm going to try to get it exact. It might not be quite perfect. But vertical angles are opposite each other and they share the same vertex. All right, so do you see here how I kind of extended that diagram? So what we would say is that A, B, and C, all right, is vertical to D, B, and F. They're opposite each other, but they share that common midpoint. All right, you following me? Okay, so what it says about vertical angles is if one measurement, let's say, is 55 degrees, then the other measurement will be the exact same measurement, 55 degrees. Vertical angles have the same measurement. All right, how do we do on those four? Adjacent, complementary, supplementary, vertical. Okay? All right, so let's look at a diagram. Everybody have those blanks? Got them filled in? Okay, so in example 1, I have this diagram over here. All right? And it says, from this diagram, name me one pair of adjacent angles. Okay? One pair of adjacent angles. All right, so let's just start. I'm just going to give you one. This is not the only pair. We're just starting here. All right? We're going to explore a couple different possibilities. Does everybody see ABC? Okay? Y'all see ABC? So ABC is an angle. Which one of those points is the vertex, the middle? B. So B is the point that connects A and C together to form the angle. All right, so what it says is, in order to be adjacent, it will share a common side, all right, and vertex. So ABF, both angles, A, B, and C, and A, B, and F share the side AB. And they both share the vertex, so that makes them adjacent. Okay, so angle ABC. And make sure you use your angle symbols. Angle ABF. It looks just like what I just drew. Okay, so angle symbol is like a slanted capital L. Okay? So for complementary, the measures have to add up to 90. So what's going to kind of give it away? Yeah, the box. All right? So the box gives it away because I know that the measurements here have to add up to 90. So this angle, CBD, and then the angle DBE, they're going to add up together to make 90 degrees. For example, and I'm just making up this number, but what if this one was, looks like it's pretty evenly split. If this one's 45, and you know they have to add up to 90, okay, that makes them complementary. An angle or a side that splits a 90-degree angle, it forms two complementary angles, all right? So complementary angles add together to equal 90 degrees. So CBD, angle CBD, and angle EBD. As long as B is your middle letter, if you said DBE, that would be okay too. All right, but B has to be the middle letter because it's your vertex. It's the point that connects the sides. Go back and look at the definitions. For a supplementary angle, what do their measures add to? Supplementary. 180. And we established that 180 degrees is the measurement of a straight line. Are we right? Okay, so now what's going to happen is these two angles have to add up to equal 180 degrees. So FBA, right here, and ABC are supplementary. They both lie on the same straight line. Okay? All right. You with me? Okay, look up here at the screen. Okay, so I'm going to back up on this one. Look, guys. I'm going to back up on this one. Two angles have to lie on the same line. Okay, so it's got to be a straight line. Here we go. Here's my straight line. Does everybody agree that's a straight line? Yes. Now we have a line that comes off of that line right here. AB, okay? So when that happens, what we're saying is this angle added with this angle has to equal the 180, okay? So angle FBA and ABC are supplementary, okay? Because they both lie on this straight line. All right, so just let me write it down, and then we'll talk about another pair. So FBA, it's like one end of the line connecting with the other end, and angle ABC. ABC, okay? All right, so let me erase this. Do you see another straight line in here?
Yeah.
Anybody see another straight line? Let's look at that one. What's the whole straight line? A, B, D, right here, A to D, okay? The measurement of a straight line is 180 degrees, okay? So, do you see how ABC kind of makes up part of that? And then what's the other angle that would connect? CBD down here, okay? So angles, so on AD, here, let me change my color. All right, on ABD, ABC is one angle, and its supplementary angle is CBD. These angles would add up together to be 180. All right, so just bear with me. I think when we start actually solving these, it's going to make a little bit more sense. All right? Okay, now vertical angles, they're a little more straightforward, okay? Because I look for really any angle in the grid. It's got to share that vertex and be completely like on the other side. So I have CBD. Do you see how ABF is right across from it? These are vertical. So vertical is not too bad, okay? All right. So CBD and, yep, they kind of make a big X, and ABF. All right. Now, if we can get into example 2, I think it'll start kind of coming together for us once we're actually solving for what are the angles measure actually. 2, I need to identify, okay, now I'm given, all right, this looks a little simpler. All right, I'm given a little diagram here, and it says what kind of angles are these? Remember, I have 4 choices. Do these look like complementary, meaning these 2 angles would make up a 90? The answer is no. Okay, they are vertical. This one's real basic. Okay, so vertical angles, what do we say about their measurements? They're the same. So what does X equal? 70. Okay, so that one wasn't bad. Whew, finally, right? Okay, so X equals 70. All right, but now I'm going to throw something else out there. All right, and hopefully this helps make sense. Do you see this straight line right here? Okay, so you just told me that this is 70, and you agree this is a straight line too. All right, so this angle measurement is 70. So because a straight line has to be 180 degrees, what would this measurement have to be? Has to add up to 180. 110. 110 plus 70 is 180. Okay, so what I was saying in the last example, is 2 angles, okay, are supplementary when they lie in the straight line. Oops, I didn't mean to have that. The straight line is right here. Okay, here's my straight line right here, going straight through. So 70 plus 110 gives me the 180. All right, now going back to my vertical rules, if this one's 110, what's the one above it? 110, okay? All right, so that's how the angle relationships can help us figure out unknown angle measurements. All right, now, of course, on this answer, it was just X equals 70. However, we did have to say that they are vertical. It says to classify, so you got to call them vertical. Vertical angles. Okay, vertical angles. All right, let's look at the next pair. What kind of angles are these? What kind of angles are these, Lydia? What kind of angles? On the second one. They're complementary. All right, so complementary, yes. Where did my C and my O go? Complementary, okay. Who knows? It's technology. Complementary. So when they're complementary, what did I say that they're going to add up to?
90.
90. So 31 plus x plus 4 equals 90. In order for this to actually be true, the value for x has to be the difference. So is there something I could combine over here?
31 and 4.
31 and 4 to make 35 plus x equals 90. Maybe you could take it from here, solve for x. Okay, so subtract 35 from both sides and x equals 55. So what that means is if I want those two angles, these two angles together, all right, is this making a little more sense to see it this way? All right, so this is the 90-degree angle, the outside, but you see how this angle and this angle would still add up to 90. Can you see that a little better now? All right, so if this one's 31, what happens when I do 55 plus 4?
59.
So what we're saying is 31 plus 59 gives me the 90. Gives me the 90, okay? So two angles together that would add up to 90 degrees. Complementary. All right, so look at this next one. These two angles right here, what's this up here? That's a straight line, right? Which its measure adds up to what? 180, which means that these two angles have to add up together to equal the 180. So so they're supplementary because they have to add up to 180. So x plus x minus 4 equals 180. What I'm saying is these two angles will add together to equal 180. All right, what's x plus x?
2x.
2x. Minus 4 equals 180. Looks like a two-step equation now. What do I do next?
Plus 4 plus 4.
Add 4. 2x equals 184. Divide both sides by 2, and x equals 92. So what does this mean? What does this mean? How does 92 make the supplementary angles true up here?
But it
If
makes
you add
sense.
2 together, it's
Yeah.
184.
Yep.
180.
So plug in 92 for x. 92. What's 92 minus 4?
Not 88.
So what we're saying is 92 plus 88 gives us the 180 degree, and they both lie in the straight line. So they are supplementary when x is 92. If x was any other value, they wouldn't be supplementary. Okay? 92 would make them add up here to 180 degrees. All right, so we're classifying the relationship, and then we're solving for x. This is on your quiz and your test. Okay, so this section right here. So now on the next example, it's going to give me a specific angle that I need to solve for. Find the measurement of EAB. So the first thing I want you to do is I want you to find EAB on the diagram. Find it on the diagram. Can everybody see EAB? Okay. So I need to use my rules. All right, so I'm solving for this angle right here. But before I can do that, all right, I've got to kind of work with maybe this information here. All right, it doesn't really give me a whole lot on the top side of that straight line. All right, but if you see CAD, what's the measurement of CAD? 4x. And then what's the measurement of CAB?
8x.
8x plus 12. What kind of angles are those two angles? They're supplementary. So what will they add up to? 180. Put it into an equation. Okay? So the first thing I'm going to do is I'm going to try to figure out what x equals. I know that's going to help me. All right, so let's put that into an equation. 4x plus 8x plus 12 equals 180. Any like terms there that I can combine? Okay, all right, I'm just going to give you a minute because this part's review. Try to solve for x. Okay, good. CAB will be good. All right, so 4x plus 8x is 12x plus 12 is 180. I subtracted 12 to get 168. Did you guys do that? Yeah. All right, and then divide by 12, and you got x equals what? 14. Okay, so it would be helpful. Why would I want to plug it in here and figure out what CAD measures? Samuel?
So you can find how much you need for a 90-degree angle.
Okay, so what is 4 times 14?
56.
It's 56 degrees. And if this is a 90-degree angle here, EAC is a 90-degree angle, what would this top angle have to measure?
34 degrees.
It has to be 34 degrees. Do you see that, guys? They're complementary. So now I'm on the top side of that straight line. Now, if EAD is 34, look here, EAB has to be what? How can I figure it out? Do you see how it's now on the top side of that straight line? So the line EA makes two angles supplementary. So if this one's 34, you can subtract it from what? 180 to make 146 degrees. Angle EAB equals 146 degrees. What now? How did I get 146? Because do you see how BD is a straight line? And then EA, do you see how EA kind of comes off of that line? So it forms two supplementary angles.
What happened to the CAB?
CAB doesn't matter. Now, technically, CAB, all right, so on the bottom side, if it's 56, then you could, well, honestly, you could just plug in 14 for X to figure out what CAB is. But it didn't ask me what CAB was. So I don't care.
The entire thing equals 360.
It does. It does. Okay, so Joel actually put together something that is relevant that we haven't really talked a whole lot about. If I do 14 times 8, anybody know what I get? 30.
Yeah, 112.
112?
Yeah.
Right, so if I plug in 14 for X here, and I add 12, what did you say, 124?
Yeah.
Okay. What do you get when you do 124 plus 146 plus 34 plus 56? 360 degrees. Okay, and it does always add up to that. It does always add up. That's why it's in chapter 9. That's why it's in chapter 9.
So is
Okay?
that one way to check, like, if you got your
Oh, absolutely. Absolutely. And when you think about it, this was kind of like the diameter then, wasn't it? Splits it. 180 on top, 180 on the bottom. Yeah. Yep. Okay, so we're going to need lots of practice. Okay. We have not gotten to example 4. I did example 4 with 4th hour. I know we've got about 10 minutes left, and you guys are probably maxed out a little bit. So let's just time out here. We can always do example 4 tomorrow. All right, it's a 2-day lesson anyway. Let's start just working through these angle pairs on the homework assignment. We'll take the last 10 minutes to start on this, And then I need you working on the homework assignment tonight. Obviously, it's not due tomorrow, but if you want to get the most, nope, it's not due till Monday. If you want to get the most out of class tomorrow, you need to be working and get as much done as you can. Obviously, you're not spending hours because we are taking tomorrow to work on it. But think about this. If you have some problems done when we come to class tomorrow, then I can look at it. I can say, hey, like, you got this one right, or you got this one wrong, or let's look at this versus you just starting from scratch, okay? So that's why we want to get ahead as much as we can. But do remember, it's not due until Monday.